Hello viewers, in this session we are going to discuss this problem where we have to find out the critical points of this function f of x, which is equal to x minus tan inverse x minus natural log of x square plus 1, right? So before finding out the critical points of this function, let us first define the critical points, right? So the critical point of a function is a point in the domain of the function, say f of x, where the first derivative, that is f prime of x, is 0 or it is not defined, right? So the critical points of the function must belong to the domain of the function, right? So here we can see that the domain of this function f of x is given by the set of real numbers, right? Because this function it consists of three functions. That is, here we have x, which is a polynomial function. Here we have tan inverse x, which is an inverse trigonometric function, and here we have the logarithmic function. So here this polynomial function x is defined for all values of real numbers, and we know that the domain of tan inverse x is the set of all real numbers, and here we have natural log of x square plus 1, and since this term, that is x square plus 1, is always going to be greater than 0 for all x belonging to R, right? So the domain of this function is also equal to the set of real numbers, and the domain of x is that is the polynomial function is the set of real numbers, and here the domain of tan inverse x is also the set of real numbers, right? So the combined domain, that is the domain of f of x, is the intersection of the domains of these three individual functions, right? And the domain that is the intersection of these three domains is equal to R, right? So the domain of this function is the set of real numbers, and the critical points of a function is a point in the domain of the function where the first derivative is 0 or it is not defined, right? So let us first find out the derivative of f of x, that is f prime of x. So we have a d by dx of x, then we have d by dx of tan inverse x, then we have d by dx of natural log of x square plus 1. So here the derivative of x is simply 1. The derivative of tan inverse x is 1 over 1 plus x square. And here the derivative of natural log of x square plus 1 is 1 over x square plus 1. And then by chain rule, the derivative of x square plus 1 is 2x plus 0, right? Because the derivative of x square is 2x, derivative of 1 being a constant is 0. So we have now 1 minus 1 over 1 plus x square minus 2x over 1 plus x square. So we can write x square plus 1 as 1 plus x square. So now let us simplify this expression. So here we have 1 plus x square in the denominator. Here we have 1. So we have here 1 plus x square. Then we have minus 1 minus 2x. And this is 1 plus x square minus 1 minus 2x over 1 plus x square. 1 and minus 1 get cancelled. We have x square minus 2x over 1 plus x square. So the derivative, that is f prime of x, is equal to x square minus 2x over 1 plus x square. So now see here, the denominator, that is 1 plus x square, is always uh, it is always greater than 0 for all x belonging to R, right? So the critical points of this function f of x, it can be obtained by equating the derivative equal to 0, right? So when we equate f prime of x is equal to 0, then here we have seen that 1 plus x square is always positive, right? So for f prime of x to be equal to 0, the numerator must be equal to 0, right? So now here we have a quadratic expression, right? So this is a quadratic equation. So we have we can take x common here. So we have x minus 2, and here we have 0. So now this is the product of two terms that is equal to 0. So we must have x is either x is equal to 0 or x minus 2 is equal to 0. So from here we have x is equal to 2. So f prime of x is equal to 0. That is, this equation leads us to two values of x, that is x is equal to 0 and x is equal to 2. So for these two values of x, the first derivative is equal to 0. So these are the two critical points of this function, and obviously both these values of x belongs to the domain of this function, that is 0 and 2 both belongs to the domain of f of x, that is R. So x is equal to 0 and x is equal to 2 are the two critical points of this function f of x, where the derivative of this function it vanishes.